Okay, so for a void function, then I said that we have some box and we can have like some Python code here. And then we can have input, and those inputs are parameters. And then I'll show you today that parameters are really just also variables. But this one has no return value. That's a void function, or a function that does not return a value, no return value. So usually in here, like you display the screen, or maybe you send over network. And usually in here, you don't want to do calculations. Like any values that come in here, whether it's in form of list or whatever, you want those values to be tested. So here you don't want to be displaying like values and doing arithmetic operations. You just display values. So if you wanted to do arithmetic operations on a list, for example, then that would have happened in some other code that returns values because you can test, right? So that's the recommended guideline for using void functions, right? Like don't do any calculations, do them in somewhere else. Just send the list that's ready to go, and then you just iterate the list and display values. Because if you're doing calculations here, you can't test, like you can't test them. So because we're not returning values. Okay, so that's a void function, and we've been using those. Like, let me go to the code space if I can find it. I think it's this one, but let me go here to my GitHub. Okay, so while that maybe it comes up fast. Yeah. I have to wait for the code. I mean, we've been using void functions. They do not return a value. For example, the multiplication table accepts input. We do something with that input, and here we're like creating a very simple multiplication table, right? And if we go up here, then nested while loop, we're just running this code to demonstrate the usage of outer and inner loops, and there's no return statement, no return statement. So in essence, they are void functions. They do not return a value. And I think even validate user input, right? It was doing this. So those are functions that do not return a value. We already knew that. But what we want to do today is we want to understand how functions work and the rules for variables and functions, and if we create a variable in a function, can we use it outside the function? Or if we create a variable outside the function, can we use it inside the function? So we want to look at those cases to see what's going on. And that concept holds true for functions that do not return a value and functions that return a value. So just to refresh your memory, so if we have a function that returns a value, then we have some Python code, and then we'll have some input parameters, and then this one does have output. And usually these are good because we can test that output, right? So here, Python code usually changes or does some algorithm to this input, and then it's spit out in some other format, right? And then we can test that. So that's the main difference between functions that don't return a value, functions that return a value. And this ones, we like them because they can help us test stuff, right? So let me go here. And here, I think we can close this piece, close all. And then we can go into a new folder. So go into functions. And we can create a very simple example for void functions, although we already know. We can say, like, for example, say hello, we'll accept some input. And then we will just simply say print hello. And whatever name is, we will append it or concatenate it to hello. We can go into main and we import void functions, and then we can say void functions dot say hello, and then we can say, like, send in some value, right, like Python, and we can say hello here. Okay, so what we want to investigate is, can we create a variable in here? For example, we say like some value equals something, right, like C++. So this one we know we can use here. We can say val. Within the function, we can use it. So we go back to main. Then notice hello Python C++. So now we're like, well, can we say print val? And it's warning us here, right away, like val is not defined. So we're like, well, okay, well, let me see what happens if I try to run it. And it doesn't work, right? So why doesn't it work? Because val only exists in this code block. So if maybe we go and look at the function. So this is a void function, right? So if we declare val in here, in this area, if we declare val here, then val only lives within this box. It cannot be accessed outside the box. And we want to understand why. And to do that, we have to understand a little bit about memory in programs, and just bear with me, right? So let's kind of get a high-level overview of memory in computers, right? So we go here, and it's kind of like, okay, so computer memory. This is a very high-level block diagram, right? Or diagram. So we have, like, assuming this is the computer's memory. Then anything that requires to be loaded or to run on a computer has to be loaded onto memory. Like, I'm using Windows, so Windows has to be loaded onto memory, assuming this box here, this block, is memory for Windows. And then we need memory for other programs. I'll just pick a couple of one. Like, I'm using OneNote, right? So OneNote requires memory. And then my recording tool, the Camtasia recorder, right? So the recorder needs its own block of memory. So Windows can only access this block of memory, OneNote this, and Camtasia this. Okay, So now, assuming we have Visual Studio Code on my machine, right? I have it. So assuming I'm writing Python code on my machine, so Visual Studio Code gets its own memory. And then when I create a Python program like that say hello program, that gets its own block of memory. And this is what we're interested in. Like, if we can go and peek into the memory, there's different levels of memory. Here we're interested in one. It's called stack memory. And this is where functions and its variables are loaded. Output functions and data, which are variables, are loaded, and they remain in memory while the program runs. For example, if we go back and look at the code I wrote, say hello. So this piece, when I run it, it'll be loaded onto memory along with its data with val name, which is a variable, and print, right? So how does that happen? Well, let's flip a page, right? Let's create a new page. That was just an overview so that you can understand, oh, like all programs get its block of memory. So now we're like taking a deep dive into memory, and we're just we want to understand stack and Python code. Like, how does that work? So we have the stack, and this is kind of like the scratch pad for coding, mainly because as you run your program, functions are loaded and they are in memory while they run. Once they finish running, then they are removed from memory, right? So it's a scratch pad. So we had that say hello function. Let me copy the code, right? So let me copy the code. So I'll copy this code. Okay, so what do we have here? We have some variables. We have name and we have val. Print is a function. We're not going to worry about that one, okay? So then when our program runs, say hello is loaded onto memory. So say hello is loaded onto memory, and it gets a block of memory. So assuming it got this block of memory, okay? And name has to be loaded onto memory. So name gets loaded onto memory, and its data goes here for name, right? So I'll put name, it's loaded to memory. And for now, we'll just say data gets loaded. And then val also, so val gets loaded onto memory along with its data, which is C++. Say hello is in memory only while it runs, okay? But once it stops running, then it's removed from memory. And this block of memory here is released and it's made available for reuse, right? So it's available for reuse, meaning our program can reuse those blocks of memory. So now understanding this piece, if we go back and look at this code I wrote, say hello gets loaded, it's in memory, and then it's unloaded. So by the time it's unloaded, if we try to say print val, oops, one note, it's not in memory anymore. It's removed from memory, meaning like our program doesn't know that that memory block is available. Even though data may be in memory, that data and val data may still be in memory, our program cannot access those addresses in memory. So for this reason, if we try to access val, it's not accessible because it does not exist, right? So it doesn't exist. So that's why our program's like, It's not defined. To our eyes, it's kind of like, hey, wait a minute, I did define it here. But we have to understand that val only exists in the say hello function code block. In this block here, or this block here. Not here, not here, only in that block. And it's only visible while the program function runs. Once it exits, it's not accessible anymore. So that's why we can't do something like this. Questions here?
So, they don't exist. Do you know where they go?
Technically they're still there. I mean, like, if we go back and look at this diagram, it says here released, available for reuse, right? Right here, it's available, so it's released, meaning our program cannot point or reference these addresses anymore. Available for reuse, so we can conclude that the values will still be here, but our program cannot access them. Once this is reused, then these values will get overwritten. So it's kind of like the hard drive, right? When you hit delete, they're just marked for deletion. I mean, they're not really deleted from the hard drive. The only way it's deleted from the hard drive, number one, that block of the hard drive is reused and then overwritten. Or number two, you reformat the hard drive, right? And then it's overwritten. So the same concept applies for memory.
So basically, we're talking about like two memories, maybe, or something like that.
Talking about what?
Two memories?
Two memories?
Yeah.
No, stack one memory here, stack memory, right? So maybe two memory blocks, right? One memory block here, one memory block here. I'm not sure if that's what you were trying to ask.
Okay.
Yep.
So if one variable is defined in one block of code, that variable wouldn't be retaining the same value on a different code if we write.
Right.
If we keep writing. Yeah, okay.
Yep. Yep, and we can add to that example I have, right? So let's go here. And then we're like, okay, so let me create another one. Hello world, right? I'll just create hello world, enter, and then I'll say val equals hello world, and then I want to print val. Let me remember to put this here. So let me copy this in here. Okay, so assuming we call say hello and then hello world, so from main, right? So say we're like, okay, let's call say, oops, let me use a different color. In our code, we say call say hello and run that piece with some values, and then call hello world after this one runs, right? So say hello is loaded onto memory, and it's in memory while it runs, and we have that variable val here. Once say hello finishes executing, then we're like, hey, now call hello world, right? So hello world might get this same block of memory. Hello world might get it, probably will get it, and it'll have a val variable, but it will not be this one, right? This one will probably be overwritten, and maybe val's here. Like maybe to us it's kind of like, hey, that's the same variable, but the other one was overwritten, right? It was just overwritten. So another case that may happen is within say hello, we might say, hey, well, I want to call hello world, right, from say hello. So meaning while this one's running, call say hello. So now both of them are in memory, right? So if both of them are in memory, then we have a hello world here function. And let me get the eraser here. So now here we'll probably still have the original, oops, it's erasing the original val. But then if we're loading another function that has another variable, then there'll be a different val variable here. This one's has the value hello world, right? So they're different, right? This one's in this address and this one's in this address, right? Like just we can have like two persons named John Smith or Mary Smith, but they might live in different addresses in the city, right? So this is the same case here. We just have two variables with val name, but they're two different variables. Hope that clears it up. How long are functions in memory? Just while they go through their statements, once they finish, they get unloaded from memory. Any other questions here?
Yes, sir. In the textbook, they talk about the memory and I'm sorry, the variable and the reference of the variable. Is it something like that? What are you talking about, or something different?
No, that's referring to the same thing.
Okay.
Yep. So that was, so I'll get to the question on the chat in a little bit. I mean, I have an example for that. So that was just introducing like how memory and code works, right? So if you just remember that every line of code you write will eventually be loaded onto memory, because it needs to be loaded onto memory for the program to run, right? Otherwise, like how does it work? Not work, right? So let's go to the next example. Let's see. So if we go back, let me, before I forget, this variable here, they usually refer to them as like local function variables. Oops. Because they'll only exist while the function is running. And then name is a parameter. It's in essence a variable because it can change values, right? And it will only always exist while our function is running, not any other time, right? So I want to make sure we get that straight. So we have a local function variable, meaning like it belongs to hello world function. But let's look at some other examples. Let's see, I have it here.
I have a quick question, Art.
Mm-hmm.
Down in the terminal where it's saying the name error, where is it getting that? Did you mean eval from? Is it like something that's stored in Python or something?
Yeah, it's probably trying to help us.
Okay.
Yeah.
So we shouldn't do, okay.
No, I mean, I purposely like made that fail, right? So it was just trying to be friendly and be like, did you mean this? So, okay, let me stop here.